Hello and good evening. My name is AB, and today I'm going to talk about what's chemistry. It's lesson one, module one. So, table of content. What we're going to talk about what's science, and then we're going to focus on detail about what's chemistry and why is it important. And then finally, we're going to talk about the branches of chemistry. So, what is science? Science, in basic terms, it is the use of evidence to make explanations and predictions of a natural phenomena and the knowledge made during the process. So, science is the use of evidence, and it is also the knowledge that is produced during the usage of the evidence. I know it's complicated, but it is really simple. And in reality, it's actually simple. So, what are the components of science? You have the hypothesis, the scientific inquiry, the scientific data, research, theory, and then scientific law. So, what is a scientific inquiry? Well, it is the development of new explanations for natural phenomena. So, for example, we have the development of the modern model of the atom. So at the beginning, we really didn't know what was the shape of the atom. And as time passed, scientists began to develop inquiries on how the atom looked. And as you can see, we got the John Dalton model in 1803, the J.J. Thomson model in 1904, and Ernest Rutherford model in 1911. And it keeps going until we reach the modern day model of the atom. What is scientific data? Well, data is data, but we have two types when it comes to scientific data, quantitative and qualitative. So, what's quantitative data? Well, it's data expressing a certain quantity, amount, or a range of values or numbers or a range of information. Like age and weight, you can be 100 pounds or you can be a ton, depending on how much you eat. Well, anyway, and then qualitative data is the descriptive and conceptual findings that are collected through questionnaires or questions and observation, which can, for example, you have gender and type. You can be a male or a female, or you can be a dog or a cat. There's like specific genders. There's no range in this information. Research. There are two types of research: pure research and applied research. Tamam? So pure research, it's a type of scientific investigation that seeks knowledge for the sake of knowledge itself. So for example, when Copernicus discovered that the Earth moves around the sun, why did Copernicus did his scientific inquiry about the movement of the sun? He just wanted to know, are we really the center of the universe? And he found out that no, we were just like a tiny fraction that just revolves around the sun. And then we have applied research. It's a type of scientific investigation that's undertaken to solve a specific problem. So, for example, scientists would study a specific pathogen in order to create a medicine to cure that pathogen. And as you can see, example, scientists studying COVID-19 to find a vaccine so they can sell it. If you have heard of Pfizer and these companies. And then we have theory. What is a theory? Well, it's an explanation of a natural phenomenon that's supported by many experiments, but still subject to change, and it only becomes valid if it can make predictions that are proven to be true. So let's imagine that you can see thunder in front of you, and then we see thunder, but we don't know why thunder happens. So scientists develop some explanations, but these explanations are not scientific laws because they are not proven yet. So any explanation for a phenomenon that is not proven yet can be called a theory. For example, we took this at school. When scientists explained the photoelectric effect, they explained it as a result of light wave characteristic, which led to the theory that sunlight is composed of waves. But in reality, it's both wave and a particle. So you see, the theory was not correct at the end. And then we have a scientific law. It's the description of a relationship in nature that is supported by many experiments. So a scientific law is a theory that has been proven to be right, simply. So we have three examples: the law of conservation of mass, Newton's gravitational laws, and Einstein's theory of relativity. And then we have, let's talk about chemistry, the subject you're studying now. So, what's chemistry? It's the study of matter and its changes. And what's matter? It's anything that has mass and takes space. And what makes chemistry important? Well, it's the central science. It includes everything because matter is simply everything. And science is about things. So, by definition, chemistry is the central science. What are branches of chemistry? We got organic chemistry. It's a branch of chemistry that focuses on carbon because organic means a compound or a material that has carbon in it. Inorganic focuses on substances that do not have carbon in them. Analytical chemistry, and then we have biochemistry, DNA, genes, etc. And then you got physical chemistry, which, from what I heard, is the hardest branch of chemistry. And that's it. Thank you so much and have a good day.